Hey friends, it's Rishabh, and I've been getting a ton of comments saying, hey Rishabh, can you teach me how to come up with a research idea? I'm super lost. I don't know how to come up with my topic, my science fair idea, my passion, my interest. How do I find that? Well, in this video, I cover all of that, so stick around. A brief intro about me. My name is Rishabh Jain. I'm a senior at Westview High School in Portland, Oregon, and I'll be announcing my college commitment very, very soon. But anyway, on to science research. I've published 3 papers in Nature Scientific Data, BMC Bioinformatics, and Frontiers in Oncology as a high schooler. And so I think I have a fair opinion and some fair advice for other high schoolers looking to publish research or looking to just explore their passions in this wonderful thing we have called science. And so I've also had my experiences in conferences as well as science competitions and research competitions for high schoolers like Regeneron ISEF, Broadcom Masters, Junior Science and Humanities Symposium, and I have won the top honors at all of those competitions. And so I truly feel like I have the perspective and the knowledge and the experiences to guide you on this. So that being said, my channel is really all about this kind of STEM areas. If you're a highly motivated student and any of this sounds kind of appealing, do be sure to subscribe so you don't miss out on future videos. And I have a ton of other videos. I have a full playlist about science research, so be sure to check that out after this video. But today we're going to be covering first an introduction to this idea of scientific research. How do we come up with that idea and that passion? Then I'm going to be walking you through the process step by step. I'm finally going to be giving you some examples and free resources for executing this and how you can really incorporate that process into coming up with your passion and your idea. And then finally, this is some bonus info. In section 4 of this video, I'm going to be going over some science fairs, research competitions, publications, and how to actually execute like the full research procedure and how to get to that final stages. And so that being said, one really, really quick important thing. This video is not for everyone. This is truly for people who want to do science research. This isn't something that just, one day you'll complete a project in one day and somehow, you'll publish a research paper based off of that. This is truly an iterative process that takes a lot of learning, a lot of experimentation. And so, really, really only watch this video if you have the time to go through every single detail. If you're going to be skipping around, please, click off this video and come back some other time. This is truly for dedicated, detailed people who want to watch each and every second of this video to find out, this whole process. And I truly feel like I can take this idea that's in my brain and plant it in yours and let it develop and plant that seed in you to grow a tree if you watch this full video. And so that being said, first, just some quick advice, in this highly competitive thing, a lot of people who compete in science fairs and science research competitions in high school, you'll see stuff like, AI, carbon nanotubes, crypto, drones, Alzheimer's disease, all these huge, big topics, which are often really, really exciting. But today I'm going to tell you to focus on your passion, and I'm going to teach you how to find what you're interested in. It could be one of these things, but you don't have to say like, hey, I'm interested in biochemistry, but I have to incorporate AI. I have to bring in blockchain into this project. You genuinely don't. Right? You'll just see that oftentimes these are really popular projects because they're popular fields to work in. But last year, I won the Regeneron International Science and Engineering Fair on a problem that is decades old and is not super popular. I won, one of the biggest awards that a high schooler can win using a project that doesn't necessarily have a lot of these random buzzwords in it. And so I'd truly like you to, kind of toss out some of that preconceived notion that I think a lot of high schoolers and competitive students might have and truly work with me on this. So that being said, in section 2 of this video, let's talk about the whole process of this thing, right? First, we're going to talk about how you can find what you're interested in. Then I'm going to go into a literature dive. How do you dive in and extract the information you need? And third, I'm going to talk about how you actually select that question that might become your project, your research publication, your idea. So this is super exciting. Section 2.1, your interest. How do we even find what you're intrigued in? I'm in ninth grade, let's say. I'm an eighth grader. How do I even find what I'm interested in? I don't know yet. I just like to play basketball and I'm somewhat interested in science, but I don't know exactly what I want to research yet. That's a valid experience. A bunch of people have that question and have been DMing me on Instagram and all this stuff. So here's my advice. First, I want you to begin consuming content. You probably already do this, right? If you watch YouTubers like the Kurzgesagt, I don't know how to pronounce that, I'm sorry, or podcasters like Lex Friedman, there's tons of good content out there. I want you to truly seek out high quality stuff, of course. But there's a lot of good content. We live in this age of information, and so we're super fortunate to have all this knowledge surrounding us at all times. And so I want you to begin consuming content from books, videos, lectures, and blogs. I have some examples here, like there's Google's blog over here. I have this thing with this lecture thing. The reason why I have that is because in my sophomore year of high school, from YouTube, I completed Stanford's full NLP course. It had like 30 videos or something, each hours long, and it was so interesting. But the best part, it was completely available online for free for anyone. And so there's so much information out there. And so I truly encourage you to start consuming some of that content. It doesn't have to be a super in-depth thing. It can be a base level course just to start learning some skills, gaining some knowledge. And once you start consuming this content, you're naturally going to have some thoughts about it. You're naturally going to learn some things. And so I want you to start taking notes. Grab a journal, buy a diary or something, and start writing in it every day from whatever content you're consuming. Let's say you're consuming some YouTube video about some biochemistry topic, right? Write down some notes, just write some minor details about it. Once you really, the writing is so important in this because it is what catalyzes you to come up with your own questions, because you actually start to trigger those gears in your brain to start rotating and generating those ideas within you. And the third piece of this is to find what you gravitate towards. So let's touch on one quick thing. You may be overwhelmed, right? You're going to be like, hey, I'm watching like 100 science videos a day. Okay, maybe not 100, but I'm consuming 5 articles, 10 videos a day. I have so many topics. I have crypto. I have, I don't know, like drones, AI. Those are just some random buzzwords, of course. But you have so many of these topics. You should have many of these topics. This is the very beginning, right? You don't want to limit yourself down to one field specifically. You want to explore, because oftentimes passions can change, interests can shift, and so you want to explore as much as you can until you can converge onto one idea. So please don't restrict yourself at the beginning. Now dive into the rabbit hole. So Wikipedia is an excellent source to do this. So once you start consuming some content on YouTube, let's say, you hear about the super ant colonies on the In a Nutshell channel, right? And on that channel, they talk about this mega colony of ants, and you love insects, right? You're super interested in that. You want to study it on your own. But how do you move on to there? Dive into the rabbit hole. So afterwards, after watching that excellent video, you take some notes, and then you revisit it, and you're like, this was super interesting. Let me read a little bit more about it. Use Wikipedia. Why Wikipedia? You've heard from your teachers, Wikipedia is trash, don't use it. Wikipedia is actually really interesting because it has hundreds of hyperlinks and references on every single page. A requirement for Wikipedia is that people add secondary sources and tertiary sources onto their web pages, the pages they make on Wikipedia. Because of that, you're going to get access to tons of articles and tons of resources just on every page that you visit. It's honestly quite incredible, the power of this huge website that is Wikipedia. Okay, that brings us to section 2.2, the literature dive. Of course, Wikipedia is not the best source in the world, so you're going to encounter topics, you're going to encounter words from those blogs, from the notes that you're now taking, from the Wikipedia articles that you're now diving into that you have no idea what they mean. To answer those, dive deeper on Wikipedia or Google them or ChatGPT. Just type a question, what is blank? It'll give you a well-informed answer. And so if these things start to seem interesting, dive deeper in them. Read another scientific article about them. A lot of high schoolers contact me saying, I went onto elsevier.com or whatever, and I'm trying to read this article, but it's paywalled. How do I do it? there are a lot of resources that are actually free. One of these is called Sci-Hub. And so basically it allows you to kind of read articles. The idea is to remove all barriers in the way of science. And so essentially their goal is to make all paywalled articles available to people who want to use them. And so for high school students, it's a pretty cool resource. I don't personally use it because I have institutional access with an affiliation at some universities. And so I can just log into my university account. But this is pretty cool for middle school, high school students who want to start reading scientific literature. And at the end of the day, take notes on every single piece of this. Okay, so now this is an abstract concept I've developed. It's called gravitation. And so basically, you'll have all these notes. Imagine you have this journal with, or let's say you filled up around 20 pages now. That's pretty reasonable, right? So you have a bunch of different topics, you have some keywords, you have some notes, some new understanding from various things. And you're like, okay, none of this is organized. How do I figure any of this out? That's good because it's all kind of in your brain and you're going to start to gravitate towards certain things. I know you may not believe it right now, but once you actually do this, you will naturally start to gravitate towards some things over others because you're not 1 year old. You've had some time on this earth to know what you kind of like, right? And so you're naturally going to, whether you know it or not, you're going to start to gravitate towards certain topics and you're going to want to dive deeper into those. So keep diving deeper into that topic. So you might have 5 topics, dive deep into each of those, you start to gravitate towards 1 or 2 subfields, dive deeper into those, and then just search up like, okay, so this field that I've came across, I keep reading articles about it, super interesting, brain-computer interfaces, neural networks, this is called computational neuroscience. Now read a review article on the state of computational neuroscience, then dive into some of those specific things. Once you do this enough, this is like kind of a process of a literature review because you gain a lot of knowledge about this. Unfortunately, you don't have an undergraduate degree or a grad degree where you've studied this stuff. So you need to start by understanding it and reading about these fields. And so once you have that, you can finally start to work towards selecting a question, which is section 2.3. So I have a gear and a question mark. The gear is for engineering. The question mark is for scientific inquiry. These are 2 main broad types of scientific research that can be done. So the gear engineering is kind of what you would expect. You're engineering a solution to a problem, some problem that everyone encounters that, hey, I don't have enough lights in my YouTube videos. How do I add more lighting? Oh, I'm going to engineer a solution to add a light bulb. Okay, that's like super very simple, and that's obviously something that's already been done. Somebody already made a light bulb, but the same thing can be said about scientific inquiry, but totally different. You're trying to answer a question, right? So let's say, why are my YouTube videos dark? Because I don't have light bulbs. So let me test out different types of light bulbs and figure out which light bulb is the best. That's scientific inquiry. That you might be working towards a solution one day, but right now you're just trying to answer a question: which light bulb is the best? So that's kind of the split difference. And I want you to try to figure out which one, based off of your ideas and the questions that naturally arise through reading these articles, that you're kind of getting into. And based off of this, you'll now have some ideas. I know watching this video right now, you're probably like, how do you just get straight to ideas? Once you really have 20, 30 pages filled in your notebook, you're going to have ideas, okay? And so with those ideas, you can start to generate some pros and cons. And some of these ideas may not even be fully fledged out, right? It's not going to be like my thing, like improving codon optimization with recurrent neural networks, right? That's the final product. You might just have this thing like, I want to work on somehow improving the effectiveness of codon optimization. And so I want to engineer some type of solution for this, but I have no idea what that is. But now you have this rough idea that's been generated, and you can start to create some pros and cons. So if you're competing in a science competition, which is something that a lot of high schoolers do who want to get feedback, I'd highly recommend competitions actually, because I feel like it truly does bring out some competitive spirit to encourage you and motivate you to work harder and learn more at the end of the day and have a lot of fun as well. So if you're interested in those types of science competitions as well, you can include that as a criteria that, hey, do I have enough time? Is this doable? Do I have the resources? How much would this cost? Those are some pros and cons you can start listing for each of your ideas. And that will help you slowly start to shift towards one. Okay, So this is kind of the rough process, and it's a little bit confusing. And so to break it down truly, I wanted to dedicate a section to examples and free resources through those examples, showing you exactly what you can do. So in section 3 here, I'm going to visit 2 projects. So a rough overview on my very, very first scientific research project. In 6th grade biology class, I learned about the body systems, and especially I focused on the exocrine system. That was mine for the human body choice project or whatever. And I learned more about the pancreas in 7th grade. I visited a lab that specialized in pancreatic cancer and had some personal ties to pancreatic cancer. And so I began to look into it a little bit more. I had a base knowledge that was developed in 6th grade biology, and I had some experiences surrounding it. And so I said, hey, let me start to dive into this idea a little bit, or not an idea, this topic a little bit more. And so from this topic, I did the literature dive. I consumed a lot of content, and so I started to read other studies about pancreatic cancer. I, looked into what are the types of things that are currently being done for this disease, and I found out there's this new technology called AI, and it's being applied to it in some ways for cancer detection. It's potentially solving some cool problems in this disease. Well, guess what? 6th, 7th grade Rishabh Jain was really interested in AI. Actually, I had an Amazon Alexa, and that was super cool. I could see how to program it. And as you can see over here, these are literally repositories from my GitHub. They're private now, but way back from like 2016, 2017, I was like literally looking into some of this stuff. TensorFlow, machine learning for osteoarthritis. So I started to play around in AI, and I started to read some stuff in pancreatic cancer. So naturally, then I went back to the literature dive that like, okay, AI plus pancreatic cancer, what's going on over here? And so I would search it in whatever thing. You can, of course, use Sci-Hub. That's an excellent resource. Search it in Google, ask ChatGPT, what are the current advancements in AI plus pancreatic cancer? And start to read articles, literature dive, take a bunch of notes. I filled up an entire notebook that year with just notes. Okay, so that's how I came up with my idea. Eventually, I dived deeper into it. I got onto radiotherapy, and I came up with a solution that used artificial intelligence to improve radiotherapy for pancreatic cancer. And now let me talk into something a little bit more in detail. This is a more recent experience, so I have a lot more to contribute to this example. And so this project I actually conducted was at the Research Science Institute. This is a summer program hosted by MIT and CEE. And so this was actually in a lab setting as well, which I think some of you might be able to relate to if you're considering getting a lab internship or research opportunity there. By the way, I have an entire video about RSI. I have an entire video about how to score well in summer programs, like how to get into those summer programs, how to get research opportunities and internships, like how to cold email, get started with a professor in a lab and stuff like that. So once again, be sure to check out those other videos. But this is literally extracts from my notes, right? The pancreatic cancer one, it's in like a journal somewhere, and so I didn't want to have to take photos of everything. But for this project, I did stuff in a Google Doc, and so I literally was able to take some screenshots and put them up on the screen for you. So as you can see, it says Rishabh, interested in biological ML, brain tumor modeling, web development, background in ML and DL for biology. So I eventually proposed this research plan for building an AI tool for brain tumor modeling, and some skills that I have, Python, MATLAB, JavaScript, intermediate, and need to learn XYZ things. Okay, so based off of this, I was able to come up with a research project, but this is just showing you some stuff. And in the bottom left corner, you can see my my browser's bookmarks. And as you can see, there's some articles bookmarked. There's an entire Dropbox with like 20 research papers. So it shows you that I went through the literature review. So as you can see, I conducted an extensive literature review to come up with my idea and understand criteria and problems in this field. So I read a bunch of papers about the state of brain tumors like glioblastoma multiforme, what is being done to model those tumors, what is being done to treat those tumors, and I came up with a bunch of different problems in these areas, some criteria for what criteria could be good for evaluating a solution to those problems. And I began to formulate this thing that, hey, can I build something that solves the current challenges in brain tumor modeling? So with that, I then worked to propose my idea. This, once again, was in a lab setting, so I actually had to propose and get feedback and get like, hey, you can work on this. And so as you can see, there's like some interesting proposals that were done on different approaches and options. And then I came up with an actual presentation. Like I had to pitch my idea. And so I had this idea that, hey, you can take a MRI scan of a patient's 3D scan, encode it, then append these different variables that I read about from the literature review from those papers, decode it, and end up predicting some sort of thing, which was an output tumor volume. And so based off of this, I now had this idea, but like, how do I do this? I say encode and decode. How do you encode and decode? Well, one of the solutions to that is using my skills in AI, which I previously acquired. And so I started to learn additional skills that I needed. I needed to learn about neural ordinary differential equations, or NODEs. And so ODEs, as you can see, I have a bunch of notes about ODEs. I read and I took notes on videos like the NIPS conference and a ton of just really, really interesting stuff here. So a ton of notes here. And as you can see on the right side here, there's some math that I had to learn. And again, I was just really taking notes through this entire process. And I think that's something a lot of people don't really look at. You know, they just start with the idea like, okay, I need to come up with an idea. What idea do I do? No, start reading, consuming content. Once you have some notes in your notebook about different fields, different topics, different hot topics you read about or heard about, then you do literature dives into those, read on Wikipedia, scientific articles, then narrow down more scientific articles, more scientific articles, more scientific articles. You start to come up naturally once you've done that with ideas and questions that you want to be answered. Decide if it's inquiry, decide if it's engineering, and then start to learn the skills. Hey, I need to solve this, or hey, I need to conduct this experiment for inquiry. What are the skills I need to do this? You read more, you consume more in order to answer those questions and come up with those skills. And so as you can see, here are some of the resources that I use, literally a YouTube video on what is a neural ordinary differential equation. It's as simple as that. And I took notes, I drew diagrams, all of this cool stuff in order to come up with the answer to those skills that I needed. Okay, so that's an example of walking through how I came up with my idea. I ended up choosing to develop an artificial intelligence model to predict brain tumor growth in the future in order to better inform radiotherapy and chemotherapy. And this didn't just pop off the top of my head. It came through reading 30 papers in this field, very, very specific. And each of those words I didn't understand, I Googled them and I learned about them, and I took so many notes in order to understand that. And then to develop the solution, that's what we're going to be talking about now. In section 4 of the video, science fairs, research competitions, publications, and doing the research. So the order, of course, is first we have to do the research. Then I'd recommend competing if you're a high schooler, because there's tons of really great opportunities for high schoolers to get feedback on their research. And then try to publish or share the findings you have with the greater scientific community so that others can learn and advance from your work. So to do the research, I actually have 2 videos made for this. One is how to get research opportunities and internships if you're looking to apply to a program or get hooked up with a lab or a professor. Another thing is how to get research published. The video is titled How to Get Research Published, but I really go into step-by-step how to do research. So beyond the literature review, what are the tools I'd recommend to do the research? What are the skills and programming languages you can start to learn? Like stuff like that. Also competitions and feedback. So I have an entire video made about STEM programs and competitions. I also have a Google Doc with literally 35 research opportunities and programs for high school students. The doc is completely free. Anyone can view it. And so check that out in the pinned comment and description, guys. I have tons of resources. I just want to make sure everyone's aware of that. And I also have a course then later, once you've completed your research and all of that, on how to make a winning science fair project, just because I have a lot of experience with that in high school and middle school. And then finally, again, how to publish. I address which journals can you apply to, how to preprint your work, all that interesting stuff. So I hope this answered your questions. If it did, please consider subscribing, because I'm sure you'll find other videos helpful in the future. If it didn't, visit my Discord server or leave a comment down below. And now watch this playlist that will take you to the rest of the very informative videos on this series.